Hi guys. So in today's video, we'll be talking about time series forecasting and uh, yeah, we'll get into some coding and some coding examples and an example project that I've been working on for a while now. So what is time series forecasting? Time series forecasting is um, using machine learning to predict future values based on previous values and using taking time as a huge factor in predicting these new values. So um, let me make a more visual explanation of this. So let's say that um, we have dates. So we have this date May 1st here, and we have May 2nd, and we have May 3rd, and we have May 4th, and we have May 5th, 6th, 7th, 8th, 9th. Now, let's say that on May 1st, we have a shop and we sell, let's say we sell shoes. So on May 1st, we sold 10 shoes. On May 2nd, we sold 20 shoes. On May 3rd, we sold 15 shoes. On May 4th, we sold 30 shoes, then we sold 29 shoes, then we sold 33 shoes. And okay, May 1st, May 2nd, 3rd, 4th, 5th, 6th. So let's say on May 7th we sold four no, let's say we sold an outrageous 100 shoes. And then on the 8th we sold 20 shoes, and on the 9th we sold 17 shoes. So you can see that there's like a pattern, like a kind of distribution between May 1st and the 9th of May. And but then we see that on 7th of May there's like some irregularity where we sold 100 shoes. So if we had to, like draw this out and represent this, we'd have something like this. Let's use this guy. Yeah, so we'll have something like this. Um, so we'd have um, let's say 10, and then 20, and then 15, and then 30, and then 29, and then 30, and then 100, and then back to 20, and then 17. So so you can see that when we plot this, it's kind of like in a wave-like format. And then let's say we keep going and we keep going and we keep going and we keep going. So time series forecasting is just us saying, okay, let's say this was May 17th. Now we want to know how many shoes we're going to sell for May 18th and 19th and on the 20th. So we want to predict these values. These are the ones we have. These are our previous sales. And now we want to predict these new values for this new timeline. So um, time series forecasting is just basically us using machine learning to fill in this missing gap and saying, okay, May 17th, May 18th, May 19th, May 20th, this are how the sales, this is, these are our predictions. So that's basically what time series forecasting is all about. And it's not just about the previous values, it's also about taking time as a huge factor, you know, into into this whole thing. So the use cases and examples of time series forecasting, um, but like the one I just mentioned now, could be in a store where we are trying to predict future values of our sales. It can also be in um, let's say we're trying to do some prediction on when a particular machine in a factory will fail based on the times that failed previously. And there's so many use cases. It can also be in the financial world. So I used to trade forex. Well, I still trade forex on stocks as a hobby. It's something I love doing. And time series forecasting can be used in this to predict the values of stocks. So let's say, yeah, if you've ever traded stocks before, this looks like this already looks like a normal trading chart, and this is time here. You know, you have time here, and then you have the price here, the price of that asset. Let's say it's a stock, it's a Tesla stock. So, and then you have the values of the stock at each particular point in time. So, um, so now let's move to what algorithms you know we can use. How do we go about time series forecasting? Well, the main thing about time series forecasting is handling your time data. You can actually use any algorithm that you want to use. You can use a linear regression model. You can build different kinds of models um, for solving this problem of time series forecasting. But the thing is that in my experience, especially for financial data, like stock prices, using the LSTM model has been really effective. And one thing I'll say about the LSTM model is this. So um, so we have time here, and at each point is a date. So let's say we're starting from the 1st of May to let's say the 20th of May. So we have all these points as dates, and at different points we have values. These are our previous values. Previous values, previous values, previous values here. So now, and then we want to predict these future values, these future times. We want to know what the stock price is. Let's use the stock market for as an example. I think that's a good example. So, um, yeah, now we have all this data at each of these time intervals. Now, you can use different models to solve this problem. You can, since you have your data points and you have your dates. So what we have is what we have here. Um, we have our data points. We have our prices. These are data points we have, and we have um, our dates. So here on the 1st of May, you have price at this particular point. You know, let's say this price here is 2.0. And here we have 0. Now you could use a linear regression model and feed these prices and these dates into it, and then and predict what the next price will be at a certain date. We could use a decision tree model. We could use different models, but there's something special about the LSTM model, and that's because we are dealing with time data. So what the LSTM model does is that it starts from here. It tries to make a prediction based off of the previous prediction. It tries to make another prediction based off of the previous prediction. and it makes another prediction based of the most recent prediction, but it also goes back into maybe the last 20 predictions. So it takes into consideration the past, and the full meaning of LSTM models are long short-term memory models. That's because the LSTM, I won't go into the details of LSTM models, but LSTM models are very good at taking data from the past and then using them with new data that you have to make predictions. So they are very good at remembering things. Let's just put it at that. They are very good at remembering things, and they are used a lot for a lot of problems in natural language processing. So after working with stock price data to try and forecast what is the new stock price will be for a particular asset, I found out that the LSTM model is it works like magic. It's really good. Like a lot of other models perform really badly, but the LSTM model performs really good. I think there are a few other models that perform really good for time series forecasting, but um, so far the LSTM model is, you know, the one that stands out, and that's what I'm talking about it here. But you can use different models. You can use a linear regression model, you can use a lasso regression model, you can use, you know, um, you can even use convolutional neural networks. Yeah, that should work, but it won't give you as much performance as the LSTM models will give you. So yeah, so let's jump into some code. I won't be coding live, but I would basically walk you through a small project I did recently because I trade a lot, so uh, I read a lot about quantum trading, and then I stumbled across a couple of things, and I started working on this project, and that actually turned out to be really interesting. So let's check it out. So yeah, so here's the project, and so in this project, basically, we are working with some data. Um, Here we have data in a CSV file, and basically, this data is for historical data. This is some historical data from a particular company that is listed in the um, under the Nasdaq assets, the Nasdaq 100 assets, and I can't remember what company it's for. But basically, you can see here we have Nasdaq 100.csv, uh, all this data. That's not what we're using. We're going to be using this. So it's for a beverage company listed on the stock market, and we have uh, data from. Let's see. We have data from 2000 and uh, basically from 2010 up to 2019, and then we're going to try to predict future stock prices. So our data stops at 2019, um, basically stops at this date. So you know we are going to try to it stops at January 4th. So we're going to try to predict the stock price of future dates. So yeah, let's go back to it. So basically, working with time series data is really pretty easy. Most of the time, you don't have like so much variables. You just basically have your dates, and you have to manipulate those dates, and then you have um, other data that you want to use in your prediction. So basically, what we are doing here is first thing we are doing is we're trying to plot uh, what we have, and we are trying to basically visualize. I won't really go into that now, but then the main thing that I want to show you guys is where we, yeah. here, this is one key point. So here we are taking the date data from the data frame. We're using pandas, as you can see. So what we are doing is we want to make sure that all our dates are in a particular format. So that's why we're using this. And that helps us like so that the data can be consistent. So once we get our dates into this particular format, we just save it back here into the date column in our on our frame, on our data frame. And one important thing is to make the date column the index of that frame, because it helps a lot, because um, you want to uh, basically you want to be able to call a data point from the frame using the date. So you don't want to have the index as 0, 1, 2, 3. No, you want to have the index as a date, because if you think about it, the dates are like very important when it comes to time series forecasting, and that's it's the dates you want to use to identify a particular data point. So you want to say on the 1st of May the stock price was this. You don't want to have um basically you don't want to have the index of that of this data frame to be 0, 1, 2, 3, or an alphabet or something else. You don't want it to be something else. You basically want it to be date. So that's why we're doing this here. And yeah, and then now, so here you can see with our data that you have the date in this format. So obviously we can't feed this into a model. I don't know of any model where you can feed this type of text data into. So one of the things we are doing um, is to try and process that date data and process it into a format that is um it's able it makes it easy for the machine learning model to identify, and also run calculations on, and you know um, do other stuff on. So that's why we have um, yeah, that's why we have this here. So also, if you take a look at our data, you can see that our price data, we are having something like 210.6, 214.9, 210.0, all those numbers. When we start calculating and when we start running calculations, and we start training our models, and we start running no complex algorithms on all those numbers, and especially when we have thousands of these numbers, um, the computation can become really slow. So we just want to scale down these numbers. Instead of having 210, we want to have a value that's like 0 0.1 to 0, something really small that we can run calculations on. And for the dates too, we have the dates in text. We want to identify the dates as values that are really small, that we can run um lots of calculations and computations at scale. So that's why we use this. So it's from the scikit-learn library. Yeah. So once we have that, then we separate our data into text and train, and we separate into X and Y. Um, and then we use keras to create a sequential model, and we just start adding different layers and different algorithms. But for this one, we are only going to be using LSTMs and a dense model, basically, because our prediction, but isn't a dense model because our prediction is going to be, it's not going to be like we're classifying something. It's going to be like we're predicting a value, and that value, like, it can be anything. It can be 100, it can be 1000, it can be 0, it can be anything. So that's what we have for our output layer, and then we have two LSTM layers. I actually really like keras. I tried to do this in PyTorch it 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 worked well, but it was way more complex than this. It was way there was it was way more complex than this basically. I was actually trying to use a convolutional neural network. Let me see if I can find it. Not this one. I think this one. Yeah. Yep, this one. So yeah. Yeah, it was not as straightforward as using Keras. Keras is really good and it's fast, and I like their approach to things. So yeah, so basically we do that and we compile the model, define our loss function and our optimizer, and then yeah, this mean squared error is really good when you're doing it's good for some particular types of use cases. So since our uh, uh, our predictions are going to be um, scalar values, basically, this will be really good for it. So then we do model.fit. But you could play around with this though, and you could play around with this, try different ones and see what works best for you. But so now we do model.fit and we pass in our values, and um, for the sake of making it fast, I'll just do one epoch, but I'll advise you do 10. Or I mean, you just play around with it to see which one works for you. And then batch size. Um, we're not really doing much of batching. And um, yeah, and this is for our command line. So um, once we do that, here we are preparing our data for testing. So we have separated our data into validation data and into training data. So now we are just going to be using some of those validation data to see how the model did. And once we do that on the validation data, we want to plot it and visualize it. So uh, yeah, and here we are just playing around with the with matplotlib to make sure that yeah, I did this to make sure that the dates when I plot it, the dates look in a very readable format. So so I can understand what I'm saying. So and there's a whole bunch of stuff that I'm doing here, but I just commented those out. Those are I was just basically trying to try out something new, but something else. But so let's try it. Let's run it and let's try it. This should take close to a minute, so it should be done after a minute. Yeah, perfect. So this is what I want to see. Yep. So if we go back to our code, um, the data we use to train the model is the one in blue. The one we use to validate the model is the one in red. And our validation predictions is the one in green. So let's look out for the one in green and see how well we did. So if we look at it, I mean, we did really well. We did really well. If I show you the results of other models compared to the LSTM model, other models were like, I mean, it wasn't really good. But the LSTM models were good. You can see that for our green, this is the blue the data in blue is basically showing um the training, what we used for training, and the ones in red are showing what we use for validation, and the ones in green are the results, uh, basically from our validation. And you can see how well it fits into the data. It's not like 100% accurate, but if you were using this to trade, this would, this will basically make you a lot of money. And yeah, I think I've made some money from this. But basically, it's very interesting what you could do with time series data. Um, so let's expand this. Uh, you can see here that I included other dates. So what I'm basically trying to do is that I'm basically trying to make predictions for these dates that are not in our data set. So this is where I get to use this model. So our data stops at 2019 first of sorry 4th of January, but I'm trying to predict what the stock price will be for the 5th, the 6th, the 7th, and the 8th. So let's go back and see. Um, so yeah, for the 4th and for the 5th, 6th, 7th, the 8th. But so basically, uh, if I was trading here, I would just say basically the stock price of this asset is going down, and I'll just start selling basically. But if you're not into trading and you don't really do trading stuff, the point basically is that I'm trying to predict the stock price here at a particular time, and this time, by time I'm using days. So 1st of May, 2nd of May, 3rd of May, 4th, like that. And instead of the stock price, it could be the amount of shoes I'm going to sell. I'm trying to predict how many shoes I'll sell at a particular time. So that's it on time series forecasting. Thanks for watching. Bye.